as you can see that when the complexity of our classes continues to grow, the code becomes less readable simply because we have to look at more code, okay? So since we need to maintain, keep maintaining everything and keep everything in good shape, what's important is that perhaps what we can do is we can go to our project, or rather, let's go back to the source folder and add another implementation file, new text document, right? Shapes.cpp. A new implementation file which with the CPP, C++ typical source extension, right? And because we are adding new implementation file, we need to go to our view our project and essentially say, let's add another file, right? Add file and go to the source and add shapes CPP, and this will be added to the sources, right? So add to the sources, we have shapes CPP, which, by the way, is an empty file, right? So what I would like to do is something like this. If I have class circle, it has constructor, it has get area, and it has get perimeter. So what I would like to do with my code is that basically I would like to take implementation of circle constructor, which obviously takes double radius, right? And place implementation of this constructor, something like this. Place implementation of this constructor in my implementation file and take the implementation out of this shape.h header file. So this can be done simply by providing a separate implementation file, and of course this implementation needs to say include double quotes shapes.h. Now the difference when we were using the headers here in main, the difference between the angle brackets when you use include and the quotes when you use include, that you tell the compiler, when I'm using angle brackets, go to your compiler libraries and try to find that file, IO manip, memory, vector, cstdlib, and so forth. Try to find it there in your compiler specific headers where all the standard libraries provided. When I use double quotes, to use double quotes with include, what happens is that instead of looking for this header file in standard library location or folders or directories, it goes to the location of main.cpp, or if I use it here, it will go to the location, the same directory where shapes.cpp is located, and will try to find shapes.h in that same directory. So that's the difference between the double quotes and angle brackets used with include, right? But shapes will bring this entire stuff into this implementation file, and when I say let's define circle constructor separately from implementation, then if I did this, I can basically reduce this entire code to just the declaration of this constructor, right? And so get area for circle and circumference and whatever else I have here, I can press Control-C, right, copy, and paste these functions inside my class. And now I need to say that circle inside my implementation file, and I need to specify that get area is this actually is a These all are versions of functions that were defined inside the circle. Inside the circle class. And so you can see that my typical style is to use a new line for my opening braces when I define my functions. All I needed to change is essentially make sure that I tell the compiler that this get area, this get perimeter, this circumference comes from the scope of the circle class. And here I just get rid of the implementation and replace it with semicolon and make this simply only a function declaration inside my declaration for this class, and likewise with circumference computation, just replace the body of the function with just the semicolon, right? So the semicolon here just basically says, look, somewhere we will provide implementation of this function, and sure enough, compiler will compile the shapes.cpp and will find implementation of this function, and therefore this function will have its own implementation. But if you look at this, I think that you can agree with me that the declaration of circle now becomes much cleaner, right? We don't obscure anything inside this class declaration with any implementation details, but we tell whoever wants to use class circle that, look, it has this data and it has a constructor which takes radius as a parameter. It has get area, it has the get perimeter. We can add additional comments to make it easier for someone to use it, and we also have some private implementation over there, and that's fine as well, right? So so this process of separating class headers from implementation of individual functions is probably the right direction. I tend to write, when I just begin writing my code, I tend to write everything in line, but then later on I usually consider adding the appropriate implementation file and moving the code over to the implementation file. So and I can even comment here in my implementation file that this is implementation for the circle class, right? For the circle, that's the class that I'm using, circle class right here, right? And I can essentially make it like a section in this implementation file just to make it stand out a little bit, make it a little easier. Then later on I can provide implementation in this file, or I can even add another implementation CPP file. Similarly, I can do this with the rectangle, right? So this time I will make it happen just like in one shot, like take all of this, Control C, copy it, paste this in my implementation file, and obviously I need to say that this rectangle thing is the constructor of the rectangle class. This get area is a function that function definition that belongs to the rectangle class scope, and likewise the perimeter also has to be prefixed with the name of the class, right? And like I told you, my habit is to actually keep just keep the opening braces on the next line, which is preference of style, right? Compiler really doesn't care about white space, but that's how you can move it out. And so therefore, I can also move the implementation. And by the way, I need to now go and say that this is my constructor over here. This is my get area, right? So there's no need for implementation because it's now provided elsewhere. Compiler will accept that. So this way, my classes become much cleaner because I can see what I can do with them simply by looking at the list of public member functions, and that is really a terrific improvement, I think, in terms of being able to read the actual implementation, the actual declarations of our classes, and see what the public interface is, that's just a little, kind of good improvement here. So let's finish it with a square as well, right? So Control C, right? Move it to our implementation file as well. I'll just add some extra lines here to push it for you to easier to see. Right, so this type of adjustment is kind of trivial, right? Just square has constructor square, and it calls rectangle constructor, and that's fine. And over here, this is just a constructor declaration, and no longer needs a definition, right? So to be consistent, I can also comment this, right? So this is whatever goes into the implementation for square. Right. Okay, so this time, obviously, I need to, again, save everything. Shift Control S works on most IDs, and then say build, and build it. So something again goes wrong. So let me fix that.